And so the first thing we're going to talk about today is how do we simplify? Well, we've been simplifying our whole lives with fractions, basically. And it's just kind of a refresher, a reminder of how to actually do it. And so for this, what we're going to do is we're going to look at it, and we're looking for the greatest common factor. So we're looking for what is the biggest number that I can divide both of the pieces of my fraction by. So if I get 25 and 30, what's the biggest number I can divide both 25 and 30 by? By 5, right? Well, if I divide both of these by 5, I end up with 5 over 6. We're good there? What's the biggest number I can divide 27 and 36 by? 9. And that's going to give me 3 over 4. Is that correct? Or what about 14 over 16? What can I divide those by? Is that 2? That gives me 7 over 8. And then finally, what about 15 over 45? Daniel? 15. I want to do that one. We end up with 1 over 3. Everybody feels pretty good about simplifying? I know it's your least favorite thing about fractions, but we're all decent there. All right, I'm going to scroll down again. For this part, simple shapes and proportions. Here's what I want you to fill in the blanks with if you're taking notes. Similar figures. Similar figures. Similar figures have the same shape, but not necessarily the same size. So here, if I wanted you to abbreviate that, here's what I want you to write. Similar shapes are same shape, different size. Similar shapes are same shape, different size. Similar shapes are, or similar figures are same shape, different size. Similar figures, same shape, different size. Same shape, different size. Okay, are we good there? Same shape, different size. So this figure right here and this figure are the same shapes, but they're different sizes. Can we all acknowledge that? What is the base of this figure right here? What is the base of this figure? Caden, what do you think? What's the base of this figure? I think, what do you think?
3.
Yeah. 1, 2, 3. Are we good there? All right, what do you think the height of this figure is? Read.
2.
Can we all agree with that?
Yeah.
Okay. Now, we've got a much larger one down here. What is the base of this figure down here?
9.
Jackson, what'd you get?
9.
9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I agree. And what is the height of this figure? Emily, what do you think?
6.
Well done. Okay, so do we agree? Same shape, different size. Well, how do I tell if they're similar figures? Here's what you're going to do. We're going to create two fractions. I'm going to have 3 over 2, and I'm going to have 9 over 6, because these are my bases, and these are my heights. Are we okay with that? Now watch what I'm about to do here. I'm going to cross multiply. What's 3 times 6?
18.
What's 9 times 2?
18.
If we end up with the same number, guess what? That means that they are similar. You guys read, what's up?
Could we just simplify them? Because 9 over 6.
Yep, you could also do that. That would work the exact same way. Reed said, couldn't we just simplify them? By having 9 over 6, if you simplify it like we did up top, you would end up with 3 over 2, which is the same thing. 3 over 2 would be equal to 3 over 2. Are we all good there? All right, next page. Okay, so we're going to use the same original figure, the 3 over 2. Alright, so we're going to leave our 3 over 2 from the top problem. We're still going to have base over height. Is everybody okay with what I mean by I'm keeping the 3 over 2? From that very first one. And now what we're going to do is we're going to do the same thing over here. We're going to do our base and our height. What's my base on this problem going to be? 1, 2, 3. And what's my height over here going to be?
8.
Alright, so what's 3 times 8?
24.
What's 3 times 2?
6.
Are those similar?
No.
Because they're different, right? Okay. So what we're doing essentially is we're setting up these proportions, and then by setting up the proportions, we're just figuring out if they have similarities to them. Alright, on to the next part. I got some basic stuff up here. This top part is the exact same thing, just talking about how similar figures are the same shape, but different sizes. And then what we're going to look at now is more specifically triangles. There's not many shapes we're going to cover in this unit. It's going to be pretty much triangles and squares or rectangles. So today we're going to focus on triangles. So I'm going to start you right here. Okay, in two similar figures, the measures of their corresponding sides or corresponding angles are congruent. I want you to write that word down, congruent. And the length of their corresponding sides are proportional. The measures of their corresponding angles are congruent, and the length of their corresponding side lengths are proportional.
Why are you talking
C-O-N-G-R-U-E-N-T.
Alright, thank you.
Congruent. C-O-N-G-R-U-E-N-T. Okay, so based off of this picture, what does angle A match up with?
Angle D.
Angle D. And what does angle B match up with? B as in boy. E. And what does C match up with? Are we all okay with that? Any questions on that? So let me go a step further. Let me ask this question. Kendall, can I ask you a question? What side does AB correspond with? AB. DE. Do we agree that AB and DE are the same? Mariah, let me ask you a question. What side does AC correspond with?
DF.
DF. And final question for Caden. What side does BC correspond with? EF. Everybody good with that part? Alright, can I drop down to the bottom triangles now?
Yep.
Now, the difference between the top triangles and the bottom triangles is I now have side lengths and angles attached to these. It's not just random pieces. We actually have numbers. I know it's a little bit faded. I'm sorry about that. We just didn't get a very good scan on it when I was uploading it. So my apologies there. But what I want you to see, though, is just because our side lengths are different, our angles are the same size. So we can all agree that these two shapes are similar, right? Because they're the same shape, but different size. Good. And so what that means, though, is that the side lengths are going to be different, but the angles on the inside are going to be the same. Does anybody know how many degrees a triangle has?
160.
Yes, there are 3 angles. Does anybody know what the sum of all 3 angles is? Kendall?
It's either 180 or 360.
180. Every single angle of a triangle has to add up to be 180. So that's why, with similar shapes, if they're the same shape but different sizes, their angles are still going to add up to 180. Do we understand that? Because every single triangle, a triangle the size of Caden and a triangle the size of me, are both going to have 180 degrees. Understood? All right, so let me ask you this. Corresponding angles. What angle matches F? Nathan, what angle matches F?
S.
S. And don't we agree that they're both 34? Okay. Rosie, what angle matches E? R, do we agree? And finally, what angle matches Q? What angle matches Q, Josh?
D.
D. Okay, let's go to our sides. I'm going to look at this from a side length now. If I give you side length 8, the measurement of 8, what side or what number is that 8 corresponding to? What number is 8 corresponding to? Samuel?
EF.
Yeah, 8 is EF. Do we agree with that? And what's it going to be for the other side now? Rosie? 24. And what side would that be, Reed?
SR.
SR. We're going to call it RS to keep them going the same way. Bottom to top, bottom to top. Are we good there? All right, so let's try this one now. What if I said ED? What does that one go to? ED.
RQ.
RQ? Are we seeing how these work?
Yeah.
Am I going too fast for anybody, or are we okay? All right. I think we're just about done with our notes.
Do we have homework today?
I'm going to try my best to say no.
Great.
I'm going to try my best to get you out of here without it. I don't want to make a promise yet. That's my goal. Okay, now, moving into the final section of this. I want to know, are these triangles similar? Are these triangles similar? So this is going to take everything that we've covered so far in class to find out if they're similar. So here's what I'm going to do. I'm going to kind of guide you through this one, and then I'm going to let you do the next one on your own. All right, so here's what I'm going to do. I'm going to pick a side. CB. If these triangles are similar, this is 102, this one's 99. Can they be the same shape? No, because what we talked about, angles are the same, sides are different, right? Now, if I want to get even more specific, though, let's set this up. I'm going to set up this one. 5 over 11. Are we okay with that?
Yeah.
How would I set it up over here?
11 over 22.
And Jackson, do you remember how I checked to see if these are proportional? Not flip them.
You cross one.
I simplify them or I cross multiply. Well, 5 times 22 I think is 110. And 11 times 11 is 121. Is that the same number? So guess what? They're not similar. Okay, what's up with this craziness down here, though? What do we notice about my triangles? Read?
All the angles are the same.
Well, all the angles are the same, but what do we notice about the difference between these two?
They're flipped.
They're flipped. Does that matter?
No.
Because technically, couldn't we flip that one back around? Here's what I'm going to do. I'm going to redraw this triangle. I'm just going to make it look just like this one. Is that pretty close? Okay, now we know that my longest side is 40 and my longest side is DF. What do you think this one's going to be?
AC.
AC. Does everybody see how I got that to be AC?
Yeah.
Okay. All right, so then my shortest side is going to be A what? And what's the length of AB? Which means that this one has to be 7. Okay. Now let me ask you this. If I multiply 10 by 4, do I get 40?
Yes.
If I multiply 4 by 4, do I get 16?
Yes.
If I multiply 7 by 4, do I get 28?
Yes.
So do you think it's similar?
Yes.
Okay, easy enough, right? All right, everybody go do your assignment real quick. I'm going to stop my video.